Hi, you guys. The plan for this assignment is I am going to do some of these with you. And then whatever we don't do together on here, the rest of it is your homework. So you need to submit this file to me with all of it filled in, but I will be filling in some of it with you. So just an FYI on that, you should be looking at this document that is linked in Canvas for you as review worksheet 5.6. So we're going to get going on some of these problems, and then you finish the rest to submit for your homework. We're going to start with number 1. It says write an equation in slope-intercept form. Okay, so that's key. You want to make sure you're writing these in the right form. Remember, slope-intercept is y equals mx plus b of the line that passes through the given point and is parallel to the graph of the given equation. So we're going to look at example 1 here. If I want to be parallel to this, you should right off the bat think, I don't need that. My current slope is 2, and when they're parallel, our slope stays the same. So I want to use a slope of 2, and this is my point. Okay. And I'm going to stick with the point slope form. I feel like the people that went right into this form before school went remote, I feel like you guys had a better grasp of that. I'm going to stick with point slope form. So if you want to do it right into this form, you are welcome to. For the sake of showing you right now, I'm doing point slope into slope intercept. So if we're going to do point slope form, let me zoom in here. This is going to be our x1 and our y1. And we're going to plug it into y minus y1 equals m times x minus x1. Okay, so it's going to be y minus 3 equals the slope 2 times x minus a negative 1, which really becomes plus a positive. Okay, and now we want to put it into slope-intercept. So we're going to start by distributing here. We're going to call this y minus 3 equals 2x plus 2, and then we would add 3 to both sides. So we get y equals 2x plus 5, and that is slope-intercept form. Okay, so that's what you're going to do on number 2 and 3 and 4, is put it into this form, either starting here, or if you like it the other way, I'll just quickly show you on number 2 how you could set it up if you like to start in slope-intercept. Okay, so this is if you're starting in slope-intercept, you have an x and a y, and negative 3 is your m. So y equals m times x plus b. So 6 equals negative 6 plus b. We would add 6. So 12 would be our b value. Okay, so if we want slope-intercept form, we need our slope and our intercept in that equation. So you would do y equals negative 3x plus 12, and that would be your answer. So just notice, these are different methods, okay? You may choose one or the other. You do not have to be able to do both. Pick the one that you like better, okay? So you'll do 3 and 4. Let's look at number 7 here, okay? In order to determine parallel, perpendicular, or neither, we have to look at what matters in an equation to tell if lines are parallel or perpendicular or neither. The answer is we need to look at the slopes of the lines, okay? So if we look at number 7, the slope of this line is right here, right? Your slope is negative 4. okay? We need to look at what will the slope be in our new line. Well, this one is in standard form, and we need to put it into slope-intercept to know what our slope is. So we're going to start by adding x to both sides. So this goes away. Now we have 4y on the left. And 14 and x you can't add together, so we're just going to call it x plus 14, or you can call it 14 plus x. So to get y by itself, we would divide by 4, and divide by 4, and divide by 4. So I'm left with y here. Remember, there's this 1 here that isn't seen. So this is technically 1/4 times x plus 14 over 4. We can just leave as 14 over 4 right now. That's fine. It doesn't impact what we're doing. So here's my new equation, which means my slope here is 1/4. Okay, so now we look at these two. A slope of -4 and a slope of 1/4. Are they the same? No, so they're not parallel. Are they opposite reciprocals? Yes, right? It flipped over. This is like -4 over 1 became 1 over 4, changed the sign. So we would say these two lines are perpendicular. Okay, so that's number 7. Just a real quick look. What would number 6 be? If x equals a number and y equals a number. Do you remember what those are? When x equals a number, that's a vertical line. When y equals a number, that's a horizontal line. What do you know about vertical and horizontal lines? They are perpendicular, right? So number 6 should be perpendicular too. Okay, so finish up 5 and 8 on those. These ones, determine whether each statement is always, sometimes, or never true. I'm going to let you guys take a look at those and see if you can figure out always true, sometimes true, or never true. And we're going to move on to here. This one says, write an equation of the line that passes through the given point and is perpendicular. Okay, so just like we did on those 1 through 4 problems, but now instead of being parallel, we want to be perpendicular. So if we look at example 12 and 13 are the easier ones because you don't have to change your form. So I'm going to look at 14 with you, okay? I want to go through this point, so this will be my x1, y1. Perpendicular to this line. Well, right now, we don't know a slope because we're in standard form. So what we're going to do is we're going to take away x from both sides, and we get the equation y equals -x plus 6. Okay, that's the only hard difference to this. When we do that, we see that our slope right now is right here. There's this 1 that's there. So our slope is -1, but we want to be perpendicular to that. So the perpendicular slope would be opposite reciprocal of -1 is +1. Okay, so we're using this slope and this point to put it into point slope form so that we can turn it into slope-intercept form. So this is going to be y minus our y value. So minus a -6 is really y plus 6 equals 1 times x minus a -5 is plus a +5. So we have y plus 6 equals, if we distribute that 1, it's just x plus 5, right? So then last step, we take away 6 from both sides, and we get y equals x minus 1. Okay, so that's what you're going to do. That one looks a lot like this one because you do need to do a little rearranging. These ones are already in the right form. So like this one, for instance, your new slope, your perpendicular slope, should be what? If our current slope is -3, then our perpendicular slope should be 1/3. So you're going to use 1/3 with this point and put that into point slope, okay? Into slope-intercept after that. Or you can start in slope-intercept if you like that way. 16 is open-ended, meaning there's a whole lot of answers you could give here. They just want to see, can you do it? Same thing with this one. Whole lot of answers you could give. Just give me a sample. Okay, let's look at these. Number 18, what is the slope of the line parallel to y equals 2? Now think about this. Y equals 2 is a horizontal line at 2. Okay, so the slope of a line parallel to that. What's the slope of this line? Well, a horizontal line has a slope of 0. So if we're going to be parallel to that, it has to be a slope of 0. Slope of the line perpendicular to y equals 2 is going to be a vertical line, and a vertical slope is always undefined. Okay. Okay, I'm going to let you figure this one out, the 20 and 21. Just notice it's x equals now, parallel and perpendicular, same idea. And then I'm going to let you just skip this one, okay? Hopefully you watch the video. Otherwise, you're going to do a problem you didn't have to do. Yeah, I will post the rest of the answers for you to check once you have submitted this.